In the beginning of this lesson, we mentioned that C allows direct access and manipulation of memory locations. We have already discussed the provision of pointer types of variables, which are used to hold the address of memory location. We also discussed how the address of operator can be used to obtain the address of memory location. If we want to directly access and manipulate memory location, we also need a mechanism to read the values stored at those memory locations. In this section, we will understand this mechanism. The process of reading the memory value stored at some memory location by making use of the base address of the memory location is called dereferencing the address. The C language has a special operator for this purpose known as dereferencing operator. Its symbol is the asterisk or the star character. When you need to dereference a pointer, you just need to apply this operator over the pointer variable like as shown on your screen. In this statement, asterisk is the dereferencing operator and PTR name is the name of the pointer variable. Let us understand the functioning of the asterisk or the dereferencing operator through an example. This statement defines an integer type of variable named var and initialize it with the value of 20. The compiler will allocate a contiguous stretch of 4 bytes and store 20 in that location. The left-hand side of the next statement creates an integer type pointer variable named PTR. The compiler will allocate 4 contiguous bytes for PTR. And the right-hand side of the same statement applies the address of operator over var and obtains its base address and stores it in PTR, which is an integer type of pointer variable. It should be reminded that the base address is the address of the first byte of a contiguous chunk of some bytes. In this case, PTR holds the address of the first byte of the 4 contiguous bytes allocated for the variable var. The next line applies the dereferencing operator over PTR. The dereferencing operator reads 4 bytes starting from the base address and casts them into an integer value and passes the value to the printf function. The output of this code is expected to be 20. That was all about how the dereferencing operator is applied over a pointer or an address. We need to dig a little deeper to have a clear understanding of the functioning of the dereferencing operator. In the given code sample, we saw that the dereferencing operator read exactly 4 bytes starting from the address pointed by PTR. But how did the dereferencing operator know how many bytes to read? If you have noticed, while declaring a pointer variable, a data type tag is also prefixed with the declaration. The data type declared at that time comes handy during dereferencing the pointer. The number of bytes to be read is inferred from the data type prefixed in the pointer declaration statement. For example, dereferencing a short pointer should read 2 bytes and dereferencing an int pointer should read 4 bytes starting from the byte pointed to by the pointer. Once the correct number of bytes have been read from the memory, they are casted into the required data type. Now you know while declaring the data type of a pointer variable is essential, because without which the compiler will never know how many bytes to read while dereferencing the pointer. Knowing the data type of the pointer variable is also essential while applying pointer arithmetic. Pointer arithmetic is something which does not work like regular arithmetic. This will be dealt with greater detail afterwards. This finishes the discussion on the application and working of the dereferencing operator. The next section deals with double pointers.